So let's kind of review here because we've seen our demand curve. We've seen our demand curve, and here's our quantity, here's our price, right? We know that the height of this guy equals our willingness to pay, right? He tells us basically marginal utility. He is really, in effect, marginal benefits. Because that's what the utility is, right? It's a benefit. We've got our supply curve here. Right? And we know that the height of this guy basically tells us marginal cost. He tells us how much each one of these individual units costs to make. So when we're looking at some price, whatever that price may be, it can be any price that we want it to be, right? We've got, say, Q1, P1. We know that this area below the demand curve but above price, we know that this guy right here is consumer surplus. Okay. We know that over here, when we had some price, and it could be anything, it could also be P1 as well if we wanted it to be Q1. We've got this area above the supply curve but below price. We know that we've said this guy is producer surplus. He's like profit, but he's not profit. For this class, it's okay to think of him as profit. What we want to do today is we want to bring these two guys together. Okay? So let's say that we're looking at a demand schedule for jeans. So we've got quantity demanded here. We have our price. We have our quantity supplied. And we're going to have some surplus shortage thing, right? So we've got these different prices here, 100, 75, 50, 25, and 10, okay? And then over here, we've got 110, 90, 60, 40, and 20, okay? Quantity supplied over here at 150. 100, 60, 45, and 5. And I'm leaving the surplus shortage stuff blank for right now. Okay? So remember we said demand is a schedule. It shows the various amounts of product which consumers are willing and able to purchase at each specific price and a series of possible prices during some specified time frame. So there's our demand schedule. We said supply was a schedule. It shows the various amounts of a product which producers are willing and able to bring to market at each specific price and a series of possible prices during some specified time frame. There's our supply schedule. Okay? So what we want to do is we've taken a demand schedule, we've taken a supply schedule, and we've stuck them together. And let's kind of draw what we get here. Okay? So here's our quantity. Here's our price, here's our demand, here's our supply, right? And we have these different prices here. So we've got this price here of, say, 50, right? And we've got a price here of 25, 10, 75, and 100. Okay? So let's take a look at this guy. And we're going to look at him in basically two different ways. So let's start off here at the top. Okay. So the graph exists, we're just not drawing this part down here. Quantity, price, supply. Here's our demand, okay? So this guy is coming down here like that, okay? So let's look at what's happening here at these different prices. Let's start off here with our price of 100. We see here at our price of 100, our quantity demanded here is going to be 20. And we see that our quantity supplied is over here. Here's our quantity supplied, and we said that this guy was 150. Okay? So let's think about what's happening here. We've got a week's worth of time. This is what this supply and demand schedule is for. At a price of 100, consumers are going to buy 20 pairs of jeans. At a price of 100, firms are going to produce 150 pairs of jeans at the end of the week. Too many or not enough? Too many, right? We've had 150 made. Consumers have bought 20. We have a surplus here of 130. Why don't consumers just buy 150 pairs of jeans? Bless you. Do what? Exactly. How much are they willing to pay for jean pair number 21? Give me a number that makes sense. Yeah, $99, right? Whatever it is. Because jean pair number 21 gives less utility than jean pair number 20. If we want them to buy 150 pairs of jeans, that can't happen at a price of 100, right? Because jean pair number 150 out here, consumers are willing to pay, well, how much would they be willing to pay? See if you can figure it out. Give me a number that would make sense. $5 sounds good, right? Because the 110th pair is they're willing to pay $10 for. Why are firms making 150 pairs of jeans? Bless you. How much does jean pair number 149 cost to make? Give me a number that makes sense. Less than 100. $98.42, whatever the number is. So if the price is 100 and it costs $98.42 to make it, it makes sense to make the pair of jeans. The problem is, of course, is that you have this surplus of 130. And it doesn't make sense to make 130 pairs of jeans every single week. That's never going to get sold. So producers compete amongst themselves and lower price, right? And as price falls to, say, we'll do it in red here. We'll do it in blue. As price falls to 75, we get this, right? Our quantity demanded changes to 40. Our quantity supply changes to 100. So at a price of 75, now we have 40 pairs of jeans that consumers want to buy every single week. Firms are making 100 pairs of jeans. At the end of the week, too many or not enough? Too many, right? We've got a surplus here of, say, 60. What's happening here with these guys? Guy number 21 all the way up to 40. Why did they enter the market? What's going on there with those people? Yeah.
Are they more willing to pay 75 for jeans instead of
Yeah. Jeans have more value to them than $75. So if the price is $75, they say, I'll do that. I'll want jeans. All the way up here to guy number 40. Guy number 40 says, I value jeans exactly at $75. What about guy number 41, 42, 43, 44, etc.? What about them? Less than 75. It's not worth $75 to them. So if the price is $75, they're like, forget it. I'm out. I don't want it. What's happening here? Exactly. It costs more than $75 to make. Jean pair number 101 costs $75.12, or whatever the number is. So if you're only going to get $75 for it, it doesn't make sense to make jean pair number 101. Jean pair number 100 costs us $75 to make. All of these pairs of jeans cost more than $75 to make, so it doesn't make sense to make them if we're only going to get $100. And you notice here that as price fell, what happened to the size of our surplus? It got smaller, right? It went from 130 to 60. What would happen if the price was not 50, but 55? What happens if our price is 55? Right, here would be our quantity demanded. Here would be our quantity supplied. This number should be somewhere around, I'll just say 57, all right? This guy should be something like 63. I mean, what's happening here with these people? What's happening here? It's the same thing that happened here. They value jeans at more than $55, right? So if the price is $55, they're like, yeah, I'll take a pair of jeans. What's happening here?
More than $55 to make them.
It costs more than $55 to make them. So if they're only going to get in $55, what do? No, I'm not making that. There's no sense to do that, right? Bless you. So the surplus here is a whole lot smaller, right? As prices are going down, that surplus is shrinking. Here we saw that the surplus would be, say, 6. What's happening right here at 50? What's happening right there?
There's no surplus.
Exactly. What we have here is that there's no surplus. Surpluses make prices fall. There's no more surplus. There's no more reason for price to fall anymore. The quantity demanded is exactly equal to the quantity supplied. And the 60th pair of jeans here is worth how much to people? Very good. And how much does the 60th pair of jeans cost to make? $50. Let's fill in this guy. Now we've got the exact opposite. Now let's start down here at this price of 10. And at this price of 10, we see that our quantity supplied here is 5. Our quantity demanded is 110. So at the end of the week, you want 110 pairs of jeans bought. People make 5 pairs of jeans. Too many or not enough? Way too low, right? We have a shortage here. We've got a shortage of 105. Right? And we can see the size of that shortage right here. Why not just make 110 pairs of jeans? Exactly. Jean pair number 6 costs how much to make? More than $10. $10.50, whatever the number is. So if jean pair number 6 costs $10.50 to make, and I'm only going to get $10 for it, what do? Not make them. Why do consumers want 110 pairs of jeans?
Because they're only $10.
So what's true about guy number 1 through 109? Louder. They're willing to pay more than $10. Jeans are worth more than $10 to them, right? Guy number 1, guy number 20 values them at 100. How much does guy number 1 value them at, right? $183, whatever the number is. Guy number 110 values them at 10. What has guy number 111 value them at? Less than 10, right? So you have 110 consumers. There's 5 pairs of jeans. There's a whole bunch of consumers in there that value jeans a whole lot more than $10, right? The 20th pair, guy number 20 values at 100. And so you have consumers competing amongst themselves. Well, I'll pay you more than $10. It's worth $15 to me. Well, I'll pay more than that. I'll go up to 20. Somebody else says, well, I'll pay more than that. I'll go up to 25 or whatever, right? And so we see the price increasing here to 25. So here's our quantity supplied. Our quantity supply changes to 45. Our quantity demanded changes to 90. Now at the end of the week, we have 45 pairs of jeans being made. Consumers want 90 pairs of jeans, though. At the end of the week, too many or not enough? Not enough, right? We have a shortage here of 45. Here we see the shortage raising price. The surplus over there made price go down. Here we see shortages are raising prices, right? What's happening here with these guys, with these suppliers? Why did these people start making jeans? Because they cost less than $25 to make, right? Jean pair number 6 through 44 costs less than $25. Jean pair number 45 costs exactly $25 to make. What happens to these people? Why do these people say, forget it, I'm out? These people value jeans at what? Less than $25. So if the price is $25, it's not worth it. Go do something else, right? Consumers continue to bid amongst themselves. The shortage gets smaller and smaller and smaller until we get up here to a price of 50. Here we see our quantity demand is equal to our quantity supplied. 60 is equal to 60. What's happening here at this price?
No surplus.
Exactly. There's neither a surplus nor is there a shortage. Surpluses make prices go down. There's no surplus. There's no reason for prices to go down. Shortages make prices go up, but there's no shortage. There's no reason for price to go up. So what we have here is we have an equilibrium price and quantity. All right. Our equilibrium price is 50. Our equilibrium quantity is 60, right? We are at this point right here where these two guys meet. Call this guy Q star. We typically call this guy P star, right? And there's no reason for us, there's no reason for price to fall anymore. There's no reason for price to rise anymore. How long will we stay there?
Until the demand is.
Exactly. We'll stay at this point until supply or demand changes, or until the world ends on Saturday, whichever comes first, all right? There's no reason for anybody to alter their behavior. If supply and demand don't change, you'll stay at that point forever. Now let's look at this guy in a different way. I really need more board space. Does everyone have this? You guys all have this? Here's our supply and demand. All right. Let's look at what happens with gene pair number 1. How much do people value gene pair number 1? Give me a number that makes sense.
Greater than 50.
Greater than what?
50.
More than 100, right? Because the 20th pair is valued at 100. So let's make up 150. Does everyone see how I got that? Right? So let's say what we got here is that our first pair, people are willing to pay $150 because that first pair gives $150 worth of utility. Doesn't mean they'll have to pay it, it just means they're willing to pay it. Okay? How much does gene pair number 1 cost to make? Give me a number that makes sense. From this data right here. The 5th pair costs 10. So gene pair number 1 could cost 5. So let's think very, very carefully about what's happening here. When we say gene pair number 1 costs $5 to make, what do we mean by that? What do you mean that it costs $5 to make? How do genes come about? They magically show up in the store. How do they come about? People get fabric. Where does the fabric come from? The store. Stores just invent fabric. Jeans are actually made out of denim, which is actually made out of cotton. So you got some farmer planting cotton. The cotton grows. He takes the cotton, processes it, sends it to a plant. They take the cotton, they turn it into fabric, they turn it into denim. Somebody else takes the denim, they cut the denim, and they sew it together, right? They color it some color. They stick it on a truck. They ship it somewhere. They put some tags on it. They take that tagged jeans, put it on another truck, stick it somewhere else, put it in a store, and they sell it, right? So you've got all of these resources that it takes to make jeans. Here's the resources. We're going to recombine them into a good or service. Jeans, all right? Cotton, labor, electricity, etc. And we're going to return it into a pair of jeans, right? All that you're doing is rearranging these resources. Okay? Right? That's all you're doing. You're just taking a bunch of these resources and you're rearranging them and combining them in new ways to create something completely different. A pair of jeans or a coffee cup or reading glasses or whatever. This first pair of jeans costs $5 to make. So we're going to take $5 worth of resources and we rearrange it into a pair of jeans that's now worth how much? $150, right? So we've taken $5 worth of resources turned it into something worth $150. Is that a good thing or is that a bad thing? That's a good thing. We took $5 worth of something and we just rearranged it. We didn't create new stuff, right? We're not God. We can't add mass to the stuff or take a mass away. We just took stuff and we rearranged it. And when we're done rearranging it, it's worth $150. So in essence, what we have here is we have this net benefit of $145. So, should we make the first pair of jeans or not make the first pair of jeans? Should, totally, right? We just created $145 worth of value just by taking some stuff and rearranging it. That's all we had to do. Let's look at jean pair number 2. Jean pair number 2 is worth $149. And jean pair number 2 cost $6 to make. We're taking $6 worth of resources, cotton, electricity, and labor, and truck transportation, and all that stuff, and we're going to rearrange it. And when we're done rearranging it, we've got a pair of jeans, jean pair number 2, and jean pair number 2 is worth $149. So this second pair here, people are willing to pay $149 because it gives $149 of utility. But our second pair here costs $6 to make. Does it make sense for us to make jean pair number 2? Yes. We took $6 worth of resources and we rearranged them into something that's worth $149. It cost a little bit more to make jean pair number 2 because of increasing opportunity costs, because of it costs more to make more. And gene pair number 2 isn't quite worth as much as gene pair number 1 because of diminishing marginal utility, but still, we just created 149 minus 2, 140, 140 something, 143? Oh, 6. There's where I'm getting from. $143 worth of net benefits, net value. Gene pair number 3. He costs $7 to make. We're going to take these resources, we want to turn them into a third pair of genes. It's going to cost $7. When we're done, we're going to have a pair of genes worth $148. We took $7 worth of resources and we turned them into something worth $148. Good thing or bad thing? Good thing, right? We don't know who's getting all of that $141 worth of excess value. It's going to the producer or the consumer. We don't know who's getting it yet. Right now, that's not important. We know that we took $7 worth of resources and then when we're done rearranging this guy, he's worth 148. Right? So here we've got second, third, $141 of new benefits. Right? Like I said, we don't know who's getting it yet, but that's not important right now. Let's look at gene pair number 59. What's happening here with gene pair number 59?
It costs $49 to make. It's on your 51.
Exactly. We're taking $49 worth of resources here with gene pair number 59. So this guy costs $49 to make. We're taking $49 worth of resources and we're going to rearrange them into something that's worth $51. Is that a good thing or a bad thing? It's a good thing. We created $2 worth of excess value, $2 worth of net benefits. So here with gene pair number 59, we've got $2 of net benefits. All right? We don't know who those $2 are going to yet, but that's not important right now. Let's look at what's happening here with gene pair number 60. How much is gene pair number 60 worth? $50. How much does gene pair number 60 cost to make? $50. So we're going to take $50 worth of resources and we're going to rearrange them into something that's worth $50. We didn't really gain anything, but we didn't lose anything either. Right? We have essentially 0 net benefits here with this guy. Let's look at what's happening here with gene pair number 61. What's happening here?
It costs $51 to make.
$51 to make. And when we're done rearranging those $51 worth of resources, we have something that's worth $49, right? So here with gene pair number 61, we're taking $51 worth of resources. And we're going to rearrange them into something, a pair of genes, that's worth $49. Is that a good thing or is that a bad thing? That's a bad thing. We took something that was worth $51 and we rearranged it into something that's now worth $49. We wasted $2 worth of benefits, right? We have net benefits here of negative. I'll do them in green here. Or let's see. We have this right? It's a loss. Now, once again, if you had an infinite amount of resources, who cares? Doesn't matter, right? If there's an infinite amount of resources and you're wasting $2 every single time you do something, who cares? You've got an infinite amount of stuff behind you to make it. But we don't have an infinite amount of resources. We have a finite amount of resources. And if we have a finite amount of resources and you're wasting $2, that's not good, right? And then you can see as you move on, you make gene pair number, I mean, whatever this number could be. It could be anything that you want it to be. Here you are out here at, say, I'll just make up some stupid number here. Gene pair number 120. All right. So here we are at gene pair number 120. This guy is worth, see, the 110th pair is worth 10. This guy is worth $5, right? So we see here gene pair number 120. He costs $80 to make, or we'll say 90. He costs $90 to make, all right? $90, all right? So here, let's look at what's happening here with gene pair number 120. We're taking $90 worth of resources, and we're going to rearrange them, which is what we do with everything. We rearrange those resources into something that's worth $5. Is that a good thing or a bad thing? That's a bad thing, right? We now have a net loss of 85, right? This net benefit here of negative 85. All right? We took $85 worth of resources and threw them away. That's what that means. Once again, in a world of infinite resources, who cares? That wouldn't matter. But we don't live in a world of infinite resources. We live in a world of finite resources. And so if we're taking stuff and we're wasting these resources, that's bad. That's not good. So we said here, hey, at this equilibrium, quantity demanded is equal to quantity supplied, right? So we know here at this equilibrium, there's lots of different things that are happening. Quantity demanded is equal to quantity supplied. There's no surplus. Surpluses make prices want to fall, but there's no reason for prices to fall because there's no surplus. There's no shortage. Shortages make prices want to rise, but there's no reason for prices to rise because there's no shortage. Price is equal to marginal cost, right? The price of these jeans is $50, which is exactly equal to what it costs to produce the next unit, right? So what we see here in equilibrium is that the price the consumers are willing to pay for the next unit is exactly equal to what it costs to produce the next unit. And then number 4, here's our consumer surplus. Here's our producer surplus. The sum of consumer and producer surplus is maximized. Okay? There's no other point that maximizes the sum of both consumer and producer surplus. And to see that that's true, choose other points. Here's our demand, here's our supply. We have this price here of 50. We have this quantity of 60. Just choose any other point that you want it to be, whatever the number is. It can be anything you want it to be. We'll stop right here. For some reason, the government says it, aliens tell us, whatever it is, it doesn't matter. We stop here at 40. We don't go to 60. This 40th pair is worth this much. Here's how much people are willing to pay. This 40th pair costs this much. Here's how much it costs to make. Right? So if we stop here at 40 and don't make any more, consumer surplus, even if the price is 50, consumer surplus is this guy. So here's our consumer surplus. Producer surplus is, let's do them in, well, I guess I'll do them in green. Producer surplus is this guy. What are these guys? What happens to this consumer surplus and this producer surplus? How much is gene pair number 40 worth? Just any number, doesn't matter. Ignore that, don't worry about that. How much is gene pair number 40 worth? $60. How much does gene pair number 40 cost to make? 25, whatever the number is, right? Ignore those numbers. $60, $25. Taking $25 worth of resources, rearranging something that's worth $60. Good thing or bad thing? Good thing, right? Should we make gene pair number 41? Yes, right? Because gene pair number 40 cost $25 to make. He was worth $60, so there was $35 worth of net benefits, right? So gene pair number 41 is going to have some net benefits. But we don't make gene pair number 41 because the aliens tell us not to make gene pair number 41. They tell us only make 40 pairs. So what happens to this consumer surplus and this producer surplus? It doesn't exist. That's exactly right. It never gets created in the first place. What about this guy over here, number 80? So this guy here is 50. This guy here is 60. Here we are out here at number 80. Here's what this guy's willingness to pay. Here's its value. Here's its cost. Just plug in some numbers, whatever numbers that you want them to be. We'll ignore all these numbers. So this guy right here is 30. This guy right here is 70. Sounds good. So what we're doing with gene pair number 80 is we're taking $70 worth of resources, we're rearranging them into something that's worth $30. Let's assume that we have to do that. The aliens say you must produce 80 pairs of jeans for whatever reason. The aliens want jeans. Good thing or bad thing? Bad thing, right? We took $70 worth of resources and we turned them into something that was worth $30. That's not good. That's wasteful, right? And so if we have this $50 here, we've got consumer surplus of this guy. We have producer surplus of this guy. And what's all this guy in here? It's exactly right. It's a loss. Because gene pair number 80, we lost $40 on. Gene pair number 79, we lose $38.50 on. Gene pair number whatever, blah, 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 blah. Right? So there's only one point on here that maximizes the sum of consumer and producer surplus. And to see that we want to maximize the sum of these guys, what price maximizes consumer surplus? Not the sum of consumer and producer surplus maximizes consumer surplus.
Is it the willingness to pay for the first pair of jeans?
What price should we charge that makes the value that consumers are paying and what they're willing to pay, that value be as large as it can possibly be? What price would that be? Zero. And how many jeans are going to be made when the price is equal to zero? None. So it can't be that we want to maximize consumer surplus. Because trying to maximize consumer surplus means we won't have any consumer surplus. What price maximizes producer surplus? Infinity. It's exactly right. And how many pairs of jeans will consumers buy if the price is infinity? Zero. So trying to maximize producer surplus means we can't maximize producer surplus because no jeans will be made. So it's not trying to maximize consumer surplus. It's not trying to maximize producer surplus. It's trying to maximize the sum of these guys that creates this. Okay, we'll pick it up from here on Monday.